Assalamualaikum viewers, welcome to my YouTube channel. I'm Bilal Academy. My name is Bilal and today I will discuss about the Txy diagrams. In Txy, the T represents the temperature, X represents the liquid phase composition and Y represents the vapor phase composition. So if we have a single component, then we use the diagrams like TS diagram, PS diagram, HS, PV and PS diagrams. And for the ternary mixture, we use the diagrams which is called as the ternary phase diagram. And what about the binary mixture? So for binary mixture, we use the Txy diagram. For example, if we have a mixture of acetonitrile and nitromethane and we put this mixture in the liquid state into a closed tank, and which will have some specified temperature and the pressure, and if we put the pressure constant and vary the temperature, and this can be done by heating the liquid mixture, and when the liquid gets heat it will convert into the vapor state. So at this time we will have two phases coexisting into the tank. So the question lies, what will be the vapor phase composition of acetonitrile, what will be the vapor phase composition of nitromethane, and what will be the liquid phase composition of acetonitrile, and what will be the liquid phase composition of nitromethane. So these questions can be answered by the Tx diagram. So first I will tell you how Txy diagrams can be constructed, and for this we use different laws. The first one is Raoult's law. Here Yi is the vapor phase composition of ith component, P is the pressure, Xi is the liquid phase composition of ith component, and Pi set is the saturation pressure, which can be calculated by Antoine equation. Here A, B, C are the constants and T is the temperature. The values of the A, B, C can be calculated experimentally and its values are given in different books as well. The second one is modified Raoult's law. Here the activity coefficient is also added and its values are also given in different books. The third one is Henry's law. Here the saturation pressure is replaced by the Henry's constant. Please keep in mind the Henry's law is used for the gas liquid equilibrium while Raoult's law is used for the vapor liquid equilibrium. Gas cannot be condensed while vapor can be condensed. The values of Henry's constant can be obtained from different books, and I have also shown the values of Henry's constant for different components as well. The fourth one is solubility. Here the product of liquid phase composition and the saturation pressure is divided by mole fraction solubility of the solute. It is the Txy diagram of acetonitrile and nitromethane mixture which is at constant pressure 70 kPa. On y-axis we have the temperature and on x-axis we have the composition of both components. The region above the Ty line is called as the vapor region and only one phase is present, which is the vapor. And the region below the Tx line is called as the liquid and only one phase, which is the liquid, is present. In between these two lines, two phases coexist, which is the liquid and the vapor. Let's say we have a mixture having a composition of 60% acetonitrile and temperature of 73 degrees Celsius. Then this point will represent the point A. And if we heat the mixture and reach at the point B, as this point is on the saturation line, so this point B will represent the saturated liquid. So there will be no vapor present at this stage, only saturated liquid. And if I increase the temperature a little bit further, then first vapor will appear. So that's why this line is called as the bubble point line. So this temperature at point B, the temperature will represent the bubble point temperature, which is 77 degrees Celsius. And if I heat the mixture further from point B, then I will reach in the liquid plus vapor region, and then I eventually will reach at point C. So if at point C I drop our temperature a little bit, then the first drop of liquid will appear. So that's why this line is called as dew point line, and the temperature at point C will represent the dew point temperature. And if I heat the mixture further, then at point I will reach at point D, which is the superheated vapor. On x-axis we have the composition. The composition of acetonitrile is represented by the black letters, and that of the nitromethane is represented by the red letters. On the right hand side, the composition of acetonitrile is 1 and that of nitromethane is 0. That means only acetonitrile is present. So the temperature will represent the saturation temperature of acetonitrile. And on the left hand side, we have only the nitromethane. So here the temperature will represent the saturation temperature of nitromethane. Let's say we have a mixture which is present at this point, and I ask you how can you calculate the vapor and liquid phase composition of both components and what will be the temperature of that mixture. For this, I will draw a tie line and extend a perpendicular line from the tie line which will cut the x-axis. As it is originated from the saturated vapor line, so the composition will represent the vapor phase composition. So 0.66 will be the composition of acetonitrile and 0.44 will be the composition of nitromethane. So for liquid phase composition, I will draw another perpendicular line from the tie line which will be originated from the saturated liquid line. So the composition will be 0.5 and 0.5 for both components. And for the temperature, I will extend the tie line and this will represent the temperature of 78 degrees Celsius. So you can calculate this type of data at any point here, here or here. So you can practice it. The Txy diagram is constructed at constant pressure. But what will happen if I change the pressure? Then the position of this two-phase region will also change. That's all from my side for the Txy diagram. If you like my video, then please subscribe to my channel so that you can get the notification of my upcoming video. Allah Hafiz.